Shit.
Oh.
So basically there are two different types of views. One is parallel view and one is perspective view. So in parallel view we have orthographic view, diametric view, isometric view and trimetric view. And in perspective we have 1 point, 2 point and it goes on. Then we have 0 point perspective view. So these are different types of perspective view. And in orthographic what we are explaining is like as we sorry, as we have studied in college in mechanical engineering, we have data planes, and when we have object in front of it, so that is projected backwards on the plane, and this will be the front view, and when it's projected downwards, this will be the top view when we have an observer here. So then my question
Mhm.
was, do you know what is first angle and third angle projection? Like how many different types of projections do we have? First angle, second angle, third angle, fourth angle. Like how many types of projections do we have?
I know only first angle and third angle.
And what about you,
Yeah,
Sri?
I think there are only four, right?
Four, four angles of
Yeah.
projections.
Yeah.
Okay. Are you sure about this?
Yeah, I mean, as far as I know, there should only be four.
Okay, as per your information, you have four. Like okay, Prabha, like how many views of projections are there in total?
Mm, like the angle of projections.
Yeah,
I know that in industry they use first angle and third angle projections. Mostly India uses first angle projection.
oh, really?
Yeah, that's what I have been taught in engineering design class.
Okay, first angle and third angle projection. Huh? So what about the other two like angles? Like, do you know what this first angle, third angle is? See, you have this.
Isn't it in the first quadrant? Like we place something in the first quadrant and what
One second,
relies
one
on
second,
the.
one second. So basically, we have done this in our school. So we have a graph sheet. We draw lines here. We have this as the first quadrant, second
Mm,
quadrant, third quadrant, and
mhm,
fourth quadrant. We have total four quadrants in a graph, right? So this will
mhm.
be the x-axis. This will be the y-axis, right? Like this. So this is what is meant by the quadrants. So now, how many angles of projections we have?
Your four angles.
Four angles. Huh? See, the thing is,
Yeah,
the
like
moment, yeah,
so when you fold it, it is only two. Yeah, you can explain.
yeah. So when you go to your interview, so they'll ask you like this. Okay, they will try to convince you that there are four angles of projections. The moment you say that, they'll ask you to just leave the room. Okay,
Mm-hmm. Yeah. Okay.
understood?
Yeah.
They
So
will
I
try
was
to
right.
convince you because if you're not confident, they'll know that this is
Uh-huh.
like you're not confident. So they'll try to convince you, and you'll say there are four angles of projections. The moment you say that, they'll ask you to please take the leave. So so you should be prepared to like. That's why you should go to the basics. You should know the basics because the very first question that they're going to ask you in interviews. Very first
Mhm.
question. They'll ask you, what is
Yep.
the third angle, like how many angles of projections are there? If you say this, then they won't wait for anything else. No explanation, nothing. They'll say, please take the leave. Let you know करके
Yeah,
देते हैं.
I remembered like say second and fourth there will be some overlaps or something.
Yeah, exactly. So I'll erase all these things. So I'll just go to that. So basically, we have this data planes again. Shit. What is this? So yeah. Just, just. So you should be very thorough with these small things, angles of
Mm-hmm.
projections and everything,
Mm-hmm.
because interview point of view, this is very important. Okay. This is very basic of 3D modeling. GD, like in the first class I had discussed, right? I think
Mm-hmm.
Srivarna was in there. GD&T,
Mm-hmm.
okay, DFMA, FMEA, okay.
Mm-hmm.
These three things are very critical, okay, when it comes to 3D modeling design. See, the thing is, if you are well versed with these things and the
Mm-hmm.
basics of design, so you can have growth in a company. You can have growth
Okay.
if you
So,
stick.
DFMA and FMEA, where did you like study?
What
Was it in
I studied it in the sense it's like in when I'm working with respect to the work I have learned. So I have not
okay.
gained any information from outside. So
Mm-hmm.
what happens is, see, DFME and FME, these two things will like if you're thorough, like if you know the details about this, you can cut cost. Okay, in a company,
Mm-hmm.
that is the most important thing, cutting cost.
Mm-hmm.
Okay,
Yeah.
the design, we can simplify the design to a manner in which you can reduce the cost. So if you make a complex design, the cost will be exponential, right? At the same time, if you take into consideration DFME and FMEA, you can make a little more simple manufacturable component, so which will save cost. Okay, so
Mm-hmm.
you can have growth in your company, and these three things are very the three pillars of growth. Understood? So
Okay.
you should be thorough with GT&T. And GT&T, the other thing is like again interview point of view. They'll ask you what
Mm-hmm.
is flatness and what is the others. What they do is they'll just draw a diagram
Mm-hmm.
and they will give this thing. They will specify like this. They'll say and they'll ask you to explain what is this. So you should explain them, and they'll ask you to give the flatness, give the other things, give the total turnout, all those things they'll give you, and they'll ask you to do it. So these are things that is going to be asked in the interviews. So do you know what is GD&T, Srivardhan?
I'm sorry, GD&T, right?
Yeah,
Yeah, yeah, yeah, geometric dimensioning and tolerancing, I think.
yeah. So do you know what it is?
Basically, it's like a set of standard symbols that specify on engineering drawings, so
Mm-hmm.
that you can specify details like or features like surface roughness
Mm-hmm.
or holes or something like that.
Surface finish.
Yeah, finish.
Yeah, flatness, parallelism, symmetries. So you guys do one thing. As an assignment, you can just make a Word document for GD&T symbols, like different types of
Hmm.
GD&T symbols, and how you're going to, where you're going to place it, how you're going to use it. Okay, that will be your assignment for next class. And
Mm-hmm.
DFMA and FMEA. So these two things, you can write down what is DFMA, what is FMEA, and you can write down certain points for DFMA. Okay,
Okay.
so you can write certain. See, I used to do this in previous batches also. I'll show
Mm-hmm.
you. Let me see one second. Delete this. Okay, where is this? No, where did I put that? See, DFMA. So like this, they used to do it. So minimize the number of components. What are the things that is to be considered? Assembly costs are reduced. The final product is more reliable because there are fewer connections. See, minimize the number of components used in the design. So you don't have to do multiple, like large number of assemblies for developing a product. So you should minimize the number of components that is used for the manufacture. Then use standard
Mm-hmm.
commercially available components. Whatever components available in market, O-rings and all those things, it's the same standard you have to use. Or else what happens is if you give the whole diameter more or something, then you won't be able to find that O-ring. So what you do is you'll have to manufacture the O-ring for that size. So it's unnecessary cost escalation. So what a component is there in the market, that same thing you have to use. Even in nut and bolts. If you have M12 bolts, you can directly put M12 holes. You don't have to put 12.7 holes. Then you have to manufacture that component again. So unnecessary cost escalations you can avoid. Use common parts across a product line. So similar products like whatever you have done component orifice means that same orifice dimension you can give for the other components. So you can save cost and time. Design for ease of part fabrication, like for part fabrication, bending and all those things. You should give enough tolerance. That enough space should be between those things, so you can do the bending operation. So all those things should be considered. Then design the product to be a foolproof during assembly. Your assembly should be in case components should be designed so that they can be assembled only one way. So what happens is like while assembling, you shouldn't give the plate backside and front side as the same thing. So what happens is when assembling, you won't know. Sometimes the person who's in the production team, they'll just assemble it like that. So it should be very different. While assembling itself, they should be able to understand key this side won't come here. So it should be designed in such a manner they can understand it. So design for ease of assembly. So it should be easier for assembly to understand it. So you should give some position marking or something in certain cases where the placement will be accurate. Okay, so like that, these many points you can see, right? So similarly, you have to make different things. What are the things that to be considered? So by reading this, you can understand, right? Key, what are the things that you should keep in mind while designing, right?
Yeah.
So similarly, what happens is if you just make a Word document like this, so before going to interview, if you just read that and go, you will have a lot of things to speak with the interviewer. So they will get impressed by straight away. They will, okay, this person is knowledgeable and he's worthy to be taken into the company. Like that kind of feeling they'll get. So that is your
Mhm.
assignment for next week. So you can just do the GD&T first, then you can do the DFMA and FMA points. You can just note down. It won't take much time. You don't have to think and write. You just have to Google it out. All the things in open source. Okay, you have Quora, you
Mhm.
have so many different websites. Okay, you have many blogs. So like in your free time, you can just Google it and you can get thousands of points. So all those things, at least 15 points each. Okay,
Okay.
if 15 points each, you can just write it, and you can save it in some drive or something, or yeah, drive you can save it. First, you send it to me for review, and you can just save it in some drive. So whichever is convenient, so that all of us, if tomorrow if some interview call comes, so you should be able to access it in such a manner. If you put
Mhm.
in laptop and if you're in some other place, so you'll be like you'll miss it out. So it's better to put it in drive, so you can just use it from your phone itself. Okay.
Okay.
Yeah. So moving on to next, what is I was doing that right? Yeah, that angles and projections. So I- so I'll just draw a component here, and I'm putting an observer here. Okay. So this person is seeing. Oh,
Mhm.
this we don't have an erase option. So we have component here, and we have an observer over here. So he's seeing from here. Okay, he's observing the product from here. So this is a product. So this product, see, this is a front view of the product where he's observing it. So this view is getting projected over here on the plane. So it's a conical shape, as you can see. So when the conical shape is projected, you get a shape called, you get a shape like this. What is the shape
Mm-hmm.
called? What is the shape called?
What is the fractal?
Yeah, it's a front view. That is okay. What is the shape called? The
Is
shape,
that a trapezium?
Fractal.
yeah, that's a trapezoid. So here the shape is called trapezoid. So when a conical, like if you have a water bottle, okay, even if you have a water bottle like this, okay, if you have water bottle like this, when you place it on a board and when you sketch outside, you get this shape. Okay, trapezoid kind of shape, conical shape will be shown later. When
Mm-hmm.
you're seeing from the front, when you're seeing from the top, you'll get a concentric shape.
Circle.
Because here smaller diameter, bigger diameter, you get a concentric shape. So this is nothing but the top view, right? So here we got the front view, here we got the top view. And similarly, when he's seeing from the side, when he's seeing from the side, that side view gets projected over here, right?
Mm-hmm.
So when he's seeing from the right side, he'll get projected here. So here we have the right hand side. So when he's seeing from the left side will get projected over here. So this will be
Mm-hmm.
the left hand side projection. What he's seeing in front that gets projected in the back side. What he sees on top gets projected in the bottom side. What he sees in the left side gets projected in the right hand side. And what he sees in the right side gets projected on the left hand side.
Mm-hmm.
So these are different projections. So when you open this thing, so it's like a box. Okay, it's like a box of different
Yeah.
views. So when you open the box, you're opening the box. So here we have the front view. Okay, this is a box. So this thing, top view, I'm just removing it. I'm opening it downwards. I'm giving it this a 90-degree angle to this. So when I give this 90-degree, when I open it 90 degrees, it'll open flat. So top view will come here. So we have here. Then when you open this 90 degrees outwards, so here we'll get the right hand side view, and this side will get the left hand side view. So this is your first angle projections. Front view on top, top view down, right hand side view, left hand side view. So when you're if you have this drafting is there. Okay, so we'll give the thing. So the main object, so the main front view will be here, the top view will be shown here, and the side view will be shown here. Okay, like this. And here by seeing the symbol. So what is the symbol of first angle projection? Can you tell me what is the symbol of first angle projection? Hello?
Sorry, I thought I was speaking and I was muted. So the trapezoid on the right and concentric circle on the left.
Yeah. So see, now you understood
Yeah,
right
on the
why.
right.
Yeah, very good.
Yeah.
So now you understood right why I use that terminology trapezoid.
Yes.
Yeah, so that's very important. Like when you're saying verbally, so that is very like the terminology is very critical. So if you say the triangle shape on the left and everything, so it's not professional kind of thing. Okay, so now
Mm-hmm.
I'll just tell you how that thing is. So we have the observer here. Okay, observer. So you're still here. Then we have the object. We have the object, and here we have the trapezoid shape. So trapezoid shape, I'm just putting it in an angle. Okay, so we have the
Mm.
observer, the object, and the trapezoid shape. Trapezoid shape is like this. Okay, so three
I
things.
think the small size, I mean the smaller length should be on the this side, left side.
Smaller length.
Yeah. So it is like unfolding, right there, right? So if the front view is folded on the left hand side, it will be, the smaller length will be on the left hand side. The conical part,
This
like the
right.
tip, will be
This
on.
shape you're saying.
Yeah, this shape will be ulta.
No, no, no. This is the standard shape. You can't change the shape. Okay.
Oh, really? Yeah, I meant like,
Oh,
okay. So
like
the
this.
projections.
Like this.
Yeah.
Yeah, that is okay. That you can put however you want. So, what I'm trying to say is, see, the definition of first angle projection is the object is in between the observer and the object. Okay, the object is in between the observer and the object. That is the definition of first angle projection. So, if you
Mhm.
remember it like this, you won't forget it. Okay, so there will be a confusion. Sometimes what happens is we'll get confused. Okay, this is first angle or that is first angle. This is third angle or that is third angle. You get a confusion. So always remember this person here. Okay, the object is in between the observer and the plane. Okay, observer and the plane. Observer and the
Okay.
plane. That is your first angle projection. Understood?
Okay.
So don't draw this person. Just in your mind, you should remember it. So you'll get a clear
Mm-hmm.
picture. So first time, see if the object is in front, the observer is always outside. He's standing here. So that means obviously it will be in the first quadrant. So you won't have much confusion. You can connect the dots. So if you remember all the dots, so there will be no room for
Mm-hmm.
confusion. But if you try to by heart it, okay, this is the symbol, it should come like this, it should come like this. So the moment somebody tries to confuse you, you'll get confused easily, right?
Mm-hmm.
So always try to make some dots and try to, it'll be much more easier for you to connect the dots. So this thing you should remember, and this is the first angle projection. So the moment you see this symbol, the moment you see this symbol on your drafting page, the manufacturing person will understand, oh, okay, so it's like this. So 100% this is the front view, this is the left hand side view, and this is the top view. So the manufacturing person will understand this. Okay. The
Mm-hmm.
main reason the angles of projection was given is because, like, if some person randomly gives some design, one side, one side, one side, one side, the manufacturing person will see this. He'll be like, "What the hell? What the hell is this? I'm not understanding. There is one hole here, there is one hole here, one hole here. So should I put holes in
Mm-hmm.
all the sides?" So he'll get confused. So he'll do something crazy and the product will be rejected. So if it is structured, and then he'll know exactly, okay, this is first angle projection, no? So that means this is the front
Mm-hmm.
view, this is the left side view, this is the top view. So this is the main reason why these angles of projections were brought into place. Okay, understood?
Okay.
So since
Yep.
this thing is opening 90 degrees, so this plane will be of no use. Wait, shit. Why did I do this? There is no eraser. Okay. There's no erase option. Let it be. So we have the third angle projection. I'll just use this angle. So the observer is here, he's still standing there. So from his point of view, this is the front view. This front view will be projected on the front plane, right? So here we
Mm-hmm.
have one more trapezoid. Here we have. Just forget about those lines. So here we have trapezoid. When I seeing from the top view, so top view is projected over here. Okay,
Mm-hmm.
understood. Similarly,
Yeah.
when I seeing the left side view is here only. When I seeing the right side view is there only. Okay, so
Yeah.
it's right opposite to first angle projection. However, also in first angle projection, exactly opposite is the third angle projection. So in third angle projection, let's just get rid of this, erase everything. So in third angle projection, we have the symbol as observer. In between the observer, we have the datum plane. Okay, and here we
Mm-hmm.
have the object. Shit. We have the object. We have the datum plane, and we have the observer. Okay.
Mm-hmm.
So what is happening? So the definition of third angle projection is the plane is in between the object and the observer. That is the definition of third angle projection. That's the only definition of third angle projection. Okay.
Mm-hmm.
So then the view, how it is. So we had the front view here, and we had the top view here,
Mm-hmm.
and we had the left side view here, and the right side view the other side. So when you're opening it up, so we have the front view here, and here we have the top
Top
view.
view.
Then here we have the right hand side view, and here we have the left hand side view. So one more
Mm-hmm.
thing, one more correction that I would like to make is, in India we prefer third angle projection. Okay,
Okay.
not first angle projection. First angle is used in Western world.
Okay.
In US and Europe, they use first angle projection. So the one
Mm-hmm.
more simple way to remember is, see, most of Indians are righties. Okay, we prefer right hand,
Mm-hmm.
right? In
Mm-hmm.
Western
Mm-hmm.
countries, like some people, like they prefer the other side, left side. Okay,
Okay.
so what? That's why, like in India, like it's much more convenient for us. See, we know this is the right side. So when we are
Mm-hmm.
observing the model, we'll equate this as the right side. Even if you have some
Okay.
drawing part drawings, so we'll automatically consider this as the right hand side, right side of the
Mm-hmm.
product. So that's why third angle projection is used in India, and in Western
Mm-hmm.
countries they use the other side. Okay, it's mostly the
Okay.
convenience aspect of it. So you can write it down. So what is the
Yeah.
definition of first angle projection, Sridhar? Not Sridhar. Yes, Srivardhan.
Uh, First angle projection, right?
Yeah, definition.
So the object is between the datum plane and the observer.
Yeah, exactly. So it's much more convenient, right? If you just remember this in
Yeah.
your mind, but don't put draw this person, right? If your interview asks you to just draw and show the symbol, don't draw this person. Let him be invisible. Okay, let him be invisible.
Mm-hmm.
Don't bring him inside this. Okay. So just remember
Okay.
this. Yeah, and remember this. Okay, always right hand side, left hand side. So our right hand side, our left hand side. So that is the third angle projection. When right hand side and left hand side is there, top view will be on top, front view will be down. Understood?
Okay.
Yes.
So yeah, so always remember this is very critical, very important. Okay, so that is a then the next is what, isometric, right? Next is isometric. Isometric again, somebody's radio's on, I believe.
What is it?
Some radio sound is coming. TV sound or radio sound, I don't know.
Oh, it's not from here.
Okay. So moving on to isometric. So what is isometric?
It's the 3D view.
Yeah, the 3D view. What does ISO mean? So just what is the thing is, it's like 30 degrees. Okay. So in
Uh-huh.
isometric views, the product is lifted at 30-degree inclination at both the angles. Okay. So here we have alpha, beta, gamma. Okay. So if this
Mm-hmm.
is 90 degrees. So this will be 90 minus 30 is how much?
60.
60. 60.
60.
60.
But
Not 60. What can be 60?
that is in the corner, right? Shouldn't that be 90 degrees?
Sorry, it's like this thing is the 120, right? 120 should come 180.
So
150,
180 minus 60, is it 45,
120,
45? Yeah, that's
120.
what one.
Yeah, it will come 120. So here also beta is also 120. So we don't know what is gamma. So alpha plus beta plus gamma. Just imagine this as the 3D, no, I mean 2D sketch. Okay. So it's a circle, normal circle. So what is the total angle of a circle?
360.
Yeah,
360.
360 degrees. So we know what is beta and gamma, 120, 120. So we don't know what is alpha. Alpha is 360
120.
plus 120 plus 120, that is 240. Oh, sorry, this is minus.
360 minus
Yeah, minus. So alpha is
120.
equal to 120. So alpha is equal to beta is equal to gamma. Is this isometric? Uh, Isometric view. Okay, in isometric view, it will be all the angles will be same. It will be lifted 30-degree at inclination. Okay. Then moving on to next. Next is what? Diametric. In diametric, two angles are same. Okay, here also we have two angles same, right? So similarly, in diametric, we have two angles same. Someone's radio is on. So I think,
Uh, no, there's nothing on here.
Yeah,
Maybe
here
someone's
too.
using a speaker or something.
yeah, I think somebody is using speaker there. I think my voice is repeated or
Yeah, I
something.
think you can hear your voice.
Oh, I will try muting.
Okay. Yeah, mute my sound.
No,
Okay.
I mean my computer.
Okay.
I don't know if it is coming from me.
Okay. So, chalo. So what I'm saying is, so over here, so it can be any other angle apart from 30 degrees. So I can give 50-50 or 60-60 or anything for that matter. Okay. Understood? So here, if it is
Yeah,
50, so 90 minus 50 is how much? 40.
40.
So 40 minus 180 is, here we have
140.
140 degrees. Here again, since it's the same thing, we'll have 140 degrees here also. So alpha, beta, gamma, alpha, beta, and gamma. So alpha
80 degrees.
plus beta plus gamma is equal to 360 degrees, same thing. So here alpha is equal to 360 degree minus how much? 140 plus 140 is 280.
Wait,
So 360 minus 280 is how much?
80.
80
80.
again, only 80. So alpha is not equal to beta equal to gamma, like this. So two angles are equal to each other. That's why we call it diametric. Dia means two. Diametric view. Okay. Coming to next, it is drawing. Next is trimetric. In trimetric, all the angles are different. And one more thing. What the hell am I doing? Something. Leave it. So here we can give two different sets of angles. Here I can give 40 or I can give 50 or anything. So this thing as usual, this will be 140 and this will be 130, I believe. 40 minus 50, 50, 130.
140.
130.
Isn't it like 180 minus 40?
No, no, no. 90 minus 40.
Oh, okay,
This
okay.
angle,
50. Okay,
then
130.
130. So, yeah. So next is this angle. So both the angles are different. So directly
90.
we'll write 360 minus 180. 180, no? 280. Not 280.
270.
Two,
Is
290.
it 150 or 130? 130 plus 140 is 270.
Yeah, I'm not able to understand when it is 130, correct? Sorry. How much is it? 270?
270.
Yeah.
So it is 90.
Yeah, so it is 90 degrees. So all the angles are different. Alpha is not equal to beta, beta is not equal to gamma. So all the three angles are not equal. This is trimetric view. So one more thing, they might ask which view do you prefer while doing this thing. So isometric is, see, if for drafting, when you're doing the drafting, huh?
Mm-hmm.
When you're doing the drafting, we do the isometric. We show the isometric view so that the
Yeah.
manufacturing person understands how the 3D model looks like. Okay, we can't put the 3D model, right? So 3D model will put like this. So the manufacturing person will understand okay, what that product is. Okay, how it will look once it's manufactured. But in the case of while modeling, this is drafting. Okay, drafting you'll put isometric. But in the when you're doing this thing, what do you say, modeling, so that time isometric view, more than isometric view, trimetric view is preferred. The reason why, I'll tell you, when it is same angle is used, okay, when the same angle is used, like the reason why we use sometimes is, the reason why we use sometimes is just like to see where the whole alignment is, or to select the lines from inside, okay, inside the body, or something like that. For that reason, we use wireframe while doing 3D modeling. Okay, so
Mm-hmm.
what happens is, so when isometric view, if you select while 3D modeling, so there will be overlap. So this line will be overlapping, edge will overlap. So it will be little difficult to select the lines and everything. Okay, so at that time, what we prefer is we use trimetric view. So trimetric view is preferred at that cases. The reason is in trimetric view, in trimetric view, the lines will be different. Okay, so you'll have lot of room to see the lines properly and select the lines like this. So since all the angles are different, it will be much more easy for you to select the lines. So when you're doing the modeling part, that we use trimetric view. In drafting, we show isometric view. Okay, is that clear?
Okay. Yes.
So have you understood these things? Different types of
Mm-hmm.
Yes.
views. So we have perspective views. Next, that also I'll tell. See, when you're one point perspective, first we'll do. So when you're, have you been on a railway track?
Mm-hmm.
Have you ever
Yeah.
felt like ending your life and have you gone to the railway track or something?
Not for ending life.
Okay. So just for sightseeing, huh? So you have gone there,
Yes.
right? Yeah. So when you stand here and when you look straight ahead, what do you see?
Yeah.
Uh,
It is like it is going
it's
And meeting
converging
at
to a point.
converge.
converging to some point, right? Why is that happening? What is the reason? What is the science behind it? Is it really going and meeting at that point?
No.
No.
No. It is our perspective view.
Why is that so? Why is that happening? See, we have two set of eyes, so it's like two cameras. One camera
Mm-hmm.
taking this picture, okay? One camera taking this picture. We don't have eyes like horses or donkeys in the side. They can see like this. They see like this, right? We see like this. We have two set of cameras right in front. So it's like these photos are mixing together. So you can see this area,
Mm-hmm.
this
The
area,
overlapping.
yeah, it's overlapping. Okay, so what is our brain doing is brain is combining these two set of photos into one single photo. So what is when this is converging like this, when these two things is there, it's trying to, when the distance increases, as the distance increases, this also increase, right? So it's trying
Mm-hmm.
to combine this set of photos together.
In an
Okay.
ultra view. Okay.
Yeah, into one view. So this point that you see, observe at the end, is nothing but the vanishing point. Okay, VP,
Mm-hmm.
vanishing point. It's called vanishing point. It's important. You can write it down. Okay. So with respect to that, I'll tell you what is one point perspective. So one point perspective. So I'll just draw a horizontal line. I'll put a perspective point. So this is vanishing point. So with respect to this, I'll draw two lines. So this case is same with anything. You take your notebook, okay, keep it, take it in your hand, place it right in front of you, and just observe. If you look, even the edges of the book will look like it's going somewhere like this.
Yeah.
So I'll just draw straight lines. Okay, I'll join this. Fuck. Okay, and I'll join this also. I'll just draw a line here. I'll draw it down. I'll draw this down. Okay, so you can see we got this 3D body. So all the edges are meeting at this point. Okay, all
Mm-hmm.
the edges are going and meeting at this point. This is your one point perspective view. Understood?
Okay.
Are we clear with this?
Yes.
All the edges are going and meeting at this point. So I'll just erase
Mm-hmm.
them. Then let's go to the 2 point perspective. So in 2 point perspective, so if you're at some junction, road junction, so there are like skyscrapers all over the place. So when you look from here, when you're standing and looking from here, you feel like all these lines are going at one point and all these things are going at some angle. You won't feel like it is straight. You'll feel like all these buildings are at some angle and going and meeting at some point. Right? You'll feel like these
Mm-hmm.
things are going and meeting at some point when you're standing at the junction and looking. So same way, I'll just draw a datum line. I'll put a
Mm-hmm.
VP point here and VP point here. Vanishing point, you can write the terminology so that you don't forget it. VP point
Mm-hmm.
here, and I just draw lines. One here, one here, one here, and another one here. And now straight lines upwards. Okay. Then I'll
Mm-hmm.
combine this again from this point, again from this point, again from this vanishing point, again from this vanishing point. Okay, so you can see we got a 3D body. So all the edges are going and meeting at this point. All the edges are going and meeting at this point, and similarly here also all these edges of this rectangular block is going and meeting at this point. Okay, so these two vanishing point is going and meeting. Right. So this is called 2 point
Mm-hmm.
perspective view.
Point.
And
Okay.
have you gone to any beaches,
Mm-hmm.
Goa beach or something?
The Marina Beach.
Marina Beach, Chennai.
Yes.
There is nothing much to see there, right? Okay.
In Nagar, there is like
Huh?
so many beaches. There are like so many beaches, and I have been to Lake Michigan Beach, but that is not exactly a beach.
It's not?
Exactly a beach. Yeah. I mean, it is a beach that North Americans say,
Mm-hmm.
but it is not like sea. It is
Marina,
as large as
Marina, Marina Trench, right?
not the marina, like Lake Michigan.
Michigan. Oh, Lake. Okay, 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 okay. Okay, it's it. So just talking about the beaches. So if you've been to beach, apart from Goa beach, if you're going to any beach, so you look at the beach. So when you're standing here, just at the see, if you're standing here, so there's a beach. You're standing here and you're looking straight. What do you see?
It's like a
You see the horizon.
Yeah, you see the
yeah.
horizon. So the horizon is how? It's just straight, right? Just a line. You
Mm-hmm.
don't see anything. You just see a straight line and nothing apart from that. You don't see anything else, right? There is no
Like it has
points.
infinite vanishing
Yeah,
points.
a vanishing point, infinite. So there's nothing there. It's just a straight line. So there is
Yeah.
no point, vanishing points or nothing. It's just plain straight things. So that's why this
Mm-hmm.
is 0 point perspective view. There's nothing more.
Okay.
Okay, that's example for 0 point perspective view. So I think you have understood all the different types of views by now, right?
Mm-hmm.
Yeah.
Can you just name all those things?
There are like two kinds of types of views: perspective view and parallel view.
Mm-hmm.
And in parallel view, there is orthographic, diametric, isometric, and trimetric.
Mm-hmm.
And we saw in orthographic, we saw two angles of projection. That is, first angle of projection and third
Mm-hmm.
angle of projection.
Mm-hmm.
And then we
First
saw
thing,
diametric
how many types of angles of projections are there?
too.
Only two. Are you sure?
Yeah.
There are four quadrants actually.
Yeah, there are four quadrants, but for the second and the fourth quadrant, the projections overlap. So there are only two angles of projections.
Okay, good.
And in the first angle, the there is an object in between the plane and the observer.
Mm-hmm.
And in the third angle, there is a plane in between the object and the observer.
Mm-hmm.
And we have isometric view where all the three angles will be equal.
Mm-hmm.
And in diametric, two angles will be equal, and in
Mm-hmm.
trimetric, none of the angles will be equal. Trimetric is preferred while modeling,
Mm-hmm. You
but
don't have to
isometric is
wait. See all the information you don't have to give like that. See, sometimes you have to give chance for them also. Even though you know the answer, you're not supposed to tell everything. You should wait for them.
okay.
Okay, so the moment you say all the thing that you know, you won't have anything left in your mind. Okay, your brain
Mm-hmm.
will be empty. So you should hold back some information, like so that if they ask, you should be able to answer it like that. Okay,
Mm-hmm.
if you tell each and everything, then they'll ask something which if they ask you something else, then you won't be able to answer it. So
Mm-hmm.
they might ask you which one do you prefer, trimetric or isometric. That's when you can use it. Okay,
Okay.
yeah. Yeah, you can tell.
Okay.
Yeah, whatever you understood, you can tell. I'm just telling you that thing because
Mm-hmm.
in
Yeah,
interview,
yeah,
if
I
you
got it.
yeah, here you can say whatever you know, you can say no big deal. So it's
Mm-hmm.
more like a revision also. But in the case of interviews, you don't have to give out all the information because if you give all the information, they'll ask something out of syllabus then, right?
Yeah.
Okay,
Yeah,
go
yeah.
ahead, go ahead.
Yeah. And isometric is preferred for drafting. So we have perspective views that 1 point, 2 point, up to infinity, and we also have 0 point view.
Mm-hmm.
In 1 point, we saw an example of train track where the point of view converges to one vanishing point.
Mm-hmm.
And in 2 points, we saw an example of like a skyscraper when we are standing in divided subline.
Mm-hmm.
So we have two vanishing points over there. And then we talked about beach view where we don't see a vanishing point, like it is just vanishing plane. So it is 0 point view.
Mm-hmm.
That's it.
Okay. Silo, then let's wind up for today. Any other doubts or
Mm-hmm.
something
Yeah.
you can ask me?
Okay. I think I don't have any doubts right now.
Mm-hmm. So don't forget about that assignment. So don't forget
Mm-hmm.
that
Yes.
GNT, DFM, DFMA, and FMA. So do it in such a manner that any interview or anything in future you can, because those things are going to come handy not just for interviews. It's like throughout your life. Okay, so you should invest
Mm-hmm.
some time into doing some research in that and get as many points as possible. GDNT, everything, write it in a very structured manner so that you'll be able to understand it even after 2-3 years. Okay, there are
Mm-hmm.
chances you'll forget it, but these things will come handy like throughout your life. Okay,
Okay.
okay, so do that,
Okay.
and yeah, that's wonderful. Okay,
Okay.
okay, I have uploaded those videos. I think you have got it.
Yes, yes.
Okay, chalo then.
Okay. Thank you.
Yeah,
Bye bye.
see ya. See you. Bye.
Thanks.
Yeah, bye. Good night.